Thanks everybody for joining us. This is Clearblade's ClearLab series, session 10, entitled Shared Caches and Timers. My name is Akash Sharma. I'm an IoT solutions engineer with Clearblade. We're a company that helps developers build IoT solutions. Over the last several sessions, we have built a system that acquires temperature data from devices connected to a Clearblade edge. The data is first stored in a collection on the edge. The collection on the edge is synced up to a collection in our platform that's in the cloud. The collection in the platform is the data source for a widget in our portal, that is our user interface. And that way, as data comes in from the devices into our edge, the data shows up in our portal. Over the last several sessions, we've also had our system occasionally retrieve temperature data from an endpoint maintained by the National Weather Service. Today, we're going to combine those two to illustrate the concepts of shared caches and timers. What is a shared cache? It is memory that's used to share information between code services. One code service writes data to a shared cache, and another code service reads that data from the shared cache. Now, you might say we already have a mechanism for sharing information between code services, and that is collections. And you're absolutely right. However, collections are data that are stored in a database, and therefore the writing and reading of collections is inherently more resource intensive and slower than writing and reading simply to memory. And that's what shared caches are, memory. That's the benefit we get from using shared caches over collection: speed and resource efficiency. A timer is a component within a Clearblade system that allows tasks to be executed on an interval or a period. We are going to modify the theme of our system slightly and take advantage of these new components to achieve our new theme. So before we make our changes, let's recall a couple of things about our system. In our system, it is the getTemperature microservice that sends HTTP requests to the National Weather Service endpoint and retrieves that temperature forecast data. And in our system, it is the log temperatures MQTT stream service that receives the absolute device temperature data coming in from the devices. And it's that stream service that stores the data to our collection. So the change in theme is going to be as follows. We're going to start treating the temperature that we're reading from the National Weather Service endpoint as an ambient temperature. And we're going to have our stream service no longer save the absolute device temperature, but rather save the difference between the device temperature and the ambient temperature. Now, why might this difference in temperature be useful in a real-world application? Well, if you think back to your first thermodynamics course, you might recall that heat transfer between two regions is related to the temperature difference between those two regions. So maybe we want to know the temperature difference between the device and the environment for a reason like that. So now our stream service needs to know about this ambient temperature from the National Weather Service endpoint. How will the stream service have access to that temperature? Well, maybe the stream service can be modified to send the HTTP request itself. Or maybe the stream service can call the getTemperature microservice to get the temperature data from the endpoint every time it needs to calculate the difference between a device temperature and this ambient temperature. In other words, an HTTP request being sent every time a message comes in from a device, possibly. Well, neither one of those is a recommended approach for three reasons. First of all, HTTP requests are inherently slow. We need the log temperatures MQTT stream service to iterate as fast as messages are coming in from devices. The last thing we want is for it to be waiting on an HTTP request, which, as I mentioned, is slow. The second reason this is not a recommended approach is the endpoint may occasionally simply not be available or not responding. In those times, it might be valuable to have the data that was cached from a previous successful request that was executed with the endpoint. And the third reason this approach is not recommended is these requests to the endpoint may not be free. There might be a cost associated with them. And the last thing we want to do is to incur a cost every time we send a request and end up sending more requests than we actually need to. For all these reasons, a better approach would be to use shared caches and timers. And that's what we're going to do. We're going to create a shared cache in our system to store the last temperature received by the getTemperature microservice. And we're going to modify that microservice accordingly to save the data into the shared cache. We're also going to modify the stream service to read the data from the shared cache, to perform the subtraction, and to save the modified temperature into the collection. Then the only question that remains is, how old is the ambient temperature that the stream service is reading from the shared cache? Well, that depends. We can actually have our getTemperature microservice refresh the data in the shared cache periodically by having it be called by a timer. So we can create a timer that fires every few seconds and have the getTemperature microservice run. Then all that remains is to decide how often do we really need to refresh that ambient temperature. Every few seconds seems the most often we would want to do it. Possibly once an hour or even once every few hours is sufficient. So by the end of this session, you will have created a timer and a shared cache. You will have modified your getTemperature microservice so that it writes to the shared cache and gets executed according to the timer. And we will have modified our log temperatures MQTT stream service to read the shared cache and save the difference in temperature between the device temperature and the ambient temperature read from the shared cache. So with all that said, let's get started. As always, I'd like you to go to platform.clearblade.com and log in. And as I always say, if you already have your temperature monitor system built such that you followed all the instructions through the end of the last session, which was session 9, then feel free to continue using that system. If you have not followed all the instructions through the end of session 9, then take your existing temperature monitor system and rename it to temperature monitor in progress, for example, and start today with the completed system as it was at the end of session 9, made available as a zip file and a support file attached to this video. And that's what I'm going to do. I'm going to add a system from a file. I'm going to browse to my file. There it is. I don't need to extract anything. I just pick the entire zip file, and there I have the system as it was at the end of session 9. Now let me go ahead and make the changes I always need. I'm going to go to my users. I'm going to go to the gear icon, go to settings, change the password of this user to something that I will remember. So go ahead and do that unless you have your own user. Same thing with devices. I'm going to go to devices, gear icon, settings, change active key. I'm going to change it to ABC123. That's what I've been using. And I'm really only going to use device 1, but I'll go ahead and change it for device 2 while I'm here. Okay. So let's go to shared caches and create our shared cache. I'm going to add a shared cache. I'm going to call it ambient temp. And the shared cache comes with a time to live that you can set to be some number of seconds or hours, and it can be a custom set. And the idea is that the data within the shared cache expires after that much time unless it has been refreshed before that time has elapsed. So I don't really need a shared cache to be to have a TTL as much as 1 hour, but I'm going to go ahead and choose 1 hour just for the purposes of this example. I'm going to go ahead and create it. And once again, which roles are allowed to use this shared cache? I'm going to choose authenticated. I'm going to let authenticated do everything that needs to be done with this shared cache. Once again, you can choose who gets to get it, get the data, who gets to set the data, who gets to delete, and so on. Authenticated can do all of that right now. Next, I'm going to go to the code and let's modify getTemperature. Now, attached to this video, you should see support files for getTemperature and for log temperatures MQTT, and they have the completed copies of all the code. But I'm going to go ahead and pick the changes. First of all, getTemperature is now going to use the ClearBlade class from the ClearBlade library. So I'm going to go ahead and add that library, add library, ClearBlade as a dependency. Second, I'm going to call this clearblade.init with the request object as a parameter, and I'm going to create an object for interacting with the ambient temp cache. Here's the code to do that. And if you want to know about the code that is needed to interact with the cache, just click on the link to ClearBlade. That'll take you to our GitHub documentation page, and here I have cache, and all the functions that we need to use to interact with our cache are listed right here. So this is what I've done. I've created an object that allows me to interact with a cache of this name. So clearblade.cache and parameter cache name is what I needed to create that object. After that, I'm going to use two functions, cache.set to set a key and its value within the cache, and cache.get to get that key from the cache. There are two other functions here that I'm not going to use that I'll just point out. One is cache.set multiple, where you can set more than one key and value. And here is set nx key, which is set a key if it does not exist. In our case, we don't care if the key exists or not. We're just going to overwrite the key every time we call our set function. But occasionally you might want to set data in the cache, and once it's set, you just don't want to overwrite it. Then this set nx function will be the one you want to use. But we're going to use set the normal one, okay? And what we're going to do next is go into where we have our resp.success. I'm going to get rid of that. And instead, I'm going to paste this code. All of this is what I would want to execute wherever I have a successful request sent to the HTTP endpoint. So what we're going to do here is we're creating a callback, and then we're creating the data that we're going to write to a key called last reading. And then we call the function cache.set. The key that we're going to set is last reading. The value that we're going to set is this JSON object right here, which has the Celsius temperature we get back from the endpoint. You might recall that we get an array of data from the endpoint, and we just pull out one element. And we're also saving the current time. The main reason I'm doing this is to show you that it actually happens periodically once we create our timer. That's really the only reason we're saving the time. Otherwise, we may not need the time, but it doesn't hurt. Okay, with all that done, let's go ahead and save and test. And we see that a temperature is being returned, and it is in Fahrenheit. So let me go ahead and change my units in test parameters from F to C. Save and test. And you see this is about 13 Celsius approximately. I want you to remember that number, because later on, we're going to see that the data that gets saved to our collection is not the absolute device temperature, but the device temperature minus about 13 Celsius. Okay. So what we're going to do next is to modify our stream service. So let's go to our stream service, log temperatures MQTT, and we have our support file, log temperatures MQTT. First thing we're going to do is to create our cache object early on right there. And the next thing we're going to do is modify our process message function such that if we are going to write a new row into our collection, we're actually going to subtract the ambient temperature before we write that row. So I'm going to take all this here, copy it, and in process message, right here where we create our new row, I'm going to replace that with what I just copied. And let's take a look at what we copied. Here we're creating a callback where it is called with error and data information. If there's no error, then what happens is essentially a new row gets created, but that new row, the temperature that's saved is Celsius temperature minus data.Celsius temperature, and data.Celsius temperature is the Celsius temperature from our shared cache. This callback is the callback for our cache.get function. So this gets the last reading item from our cache, and the callback that gets called with this function is right there. So let me quickly point out again, last reading was saved in getTemperature, and last reading is a JSON object that's got two items, Celsius temperature and time, and it is the Celsius temperature that we are pulling out right here and subtracting it from the Celsius temperature that we essentially got back from the device. Okay, so let's go ahead and save that. Now that we have modified our code services to use the shared cache, let's create our timer. There's a couple of ways we can create the timer. One way is we could go to the code that needs to be executed by the timer, getTemperature, and we can go to its timers tab and create the timer there, and then the timer will be implicitly linked to this code service. But another way, completely valid approach, would be to go to the timers page right here and create the timer from there. This is an option if we want to create a timer that is unlinked to a code service. So let me start off by doing that. Let me create a timer, add timer, and let me call this my ambient temp timer. And I'm going to have this run. I request that nobody choose forever, please. The last thing we want to do is to have a resource that's going to sit and run forever, taking up resources. Don't do that. You only want to do that in a true production system. This is not one of those. So pick other, and you can let it run a lot of times. Let's pick 200 times. That's okay. So that means that this timer is going to fire 200 times, and we can have it fire every, I'm going to choose other and say 10 seconds. So every 10 seconds, I'm going to have this timer fire. Now, the first time it fires can be at some future time. However, if whatever this future time is has already elapsed by the time I create the timer, then the first firing actually happens immediately when I create the timer. And from that point on, a firing happens every 10 seconds. So I believe this time has already elapsed. So I'm going to go ahead and create the timer. And now you're going to see that there's 199 more times that the timer is going to fire the first time, followed by 199 times. I know that can be a little bit confusing, but you'll get used to it. So right now, this timer is not associated with any code service, but apparently it's running and firing. How can I see that it's doing something? Here's how I can do that. I can open up a new tab and go to messages and test topic, and I'm going to subscribe to timer, $timer, sorry, that's a special topic, $timer, / ambient temp timer, subscribe, and now I should see a new message coming in every 10 seconds. And there you go. So every 10 seconds, you see a new message coming in. And this is how we can have possibly a stream service do something on a timer. So every time the timer fires, a message gets published to this topic. You have a stream service subscribing to that topic, and it gets the message and it does something. But that's not what we're going to do now. Now what we want is for this timer to cause the getTemperature microservice to execute. So let's go ahead to timers and click there and edit the timer and associate a code service with it right here, getTemperature, update timer. And now if I go to the code page for getTemperature, you'll see that the timers tab has the ambient temperature timer, ambient temp timer associated there. And now if I turn on logs, you'll see over here that I am logging last reading. So every 10 seconds or so, we should see, oh, I didn't save it. So let me save it. There we go. There we go. So every 10 seconds, I should see a new entry. So let's try that again. So 40 and 50. And let's try it one more time, maybe. Okay, so you get the idea. So every 10 seconds, this timer is firing. Now, we don't want all this to run in the platform. We actually wanted it to run on the edge. So to make it run on the edge, we need to modify our deployment. So let's go to our deployment, first edge deployment, and let's modify this first by going to services. And we have a new service we want to deploy to the edge, and that's getTemperature. Sync that to the edge. Next, we have a cache that we want to sync to the edge. So let's go ahead and click on that, sync that to the edge. And finally, we have a timer that we want available on the edge. So sync that to the edge, save and exit. And now we're ready to deploy all those components to our edge. So our edge is not running, so let's get it ready. So I have my terminal. Let's go to edges, setup instructions, Linux x86 64, copy the install command, paste it, and then I copy my startup command. Once the installation is done, I paste that. And if I wait till the ClearBlade ASCII art shows up, and now I can refresh, and I have my edge available to log in. So let me make sure I log in with the right credentials. And sure enough, there we are. And to make sure that the deployment did change as expected, I see I have a timer, I have a shared cache, those I didn't have before. If I go into services, I have getTemperature in there. I didn't have that before either. So now let me go into my stream service, go to my advanced tab, make sure that it's not running. It is not. Code editor, save and test, advanced, refresh. It is running. And while I'm here, let me actually just go back to the microservice and refresh that. And again, you see every 10 seconds, I'm seeing a new entry. So the microservice is being executed on that 10-second timer. Well, great. What we want is to see data coming into our portal. So let's go ahead and bring up our portal and log in with the user that we had created. And there's nothing we need to change in our portal. It's just going to show the data coming in. Let's get ready to run our adapter, new terminal, change to the adapters, temperature adapter folder. And to run, I needed some command line arguments. Let me get those ready. So go to the system information. I needed the system key, paste that there. I needed the system secret, paste that there. The device number was 1. Device key was ABC123. And if you recall, this was the device. Device 1 was the one that was supposed to publish temperature in units of Fahrenheit. So it's going to publish temperatures between 70 and 100 Fahrenheit, which corresponds approximately to 20 to 40 degrees Celsius. And we wanted to publish 100 points. But now here's the thing. If this is going to publish between 20 and 40 degrees Celsius, what we're actually going to see in our portal is between 20 minus 13 and 40 minus 13 approximately. So between 7 and 27 degrees Celsius approximately. So let's see if that's what we see. So let's get ready and run. There we go. Data is coming in. And if I see the lowest value here is about 12 Celsius, and the highest value is about 23.6. So it looks like I'm approximately getting my temperatures that I expect, and I can still do the smoothing of the temperatures by clicking on the toggle. Smooth temperature coming in, and then I click back, I get the raw temperatures coming in. So hopefully you see that there's a lot of power that comes with using shared caches to share information between code services. And there's a lot we can do with timers. We've really just scratched the surface by creating this timer that runs periodically, invoking a code service, or maybe we could have used the timer simply for the message that it publishes to an MQTT topic. So I hope this was helpful. I encourage you to follow the instructions and build this yourself. If you haven't done so, please do go through sessions 1 through 9 as well. And I look forward to seeing you at the next one. Thank you very much.